Good morning, everybody. I hope you're having a great day so far. We're going to take a look at the homework from yesterday. So if you don't have that out, please get it out now. It was on page 90. It was number 16 through 28. There were 13 problems that worked us through and walked us through the two ideas that we talked about last time we were together. One of those ideas was something that you knew way before you ever walked into my classroom. It's just we had the opportunity to kind of prove it and to reaffirm it. And that idea was the fact that any three angles inside any triangle always add up to be 180. That the three interior angles, so the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 in this picture, they have to add up to be 180 no matter what the triangle looks like. The three interior angles of any triangle always sum 180. That's super important. Something you knew a long time ago. We had the opportunity to prove it together. But the new thing, the thing that we had not maybe known or talked about before, was this idea of these exterior angles. And when we look right here, we see that angle Z is on the exterior of this triangle. We get an exterior angle by just extending one side, and then we have that exterior angle. And we said that an exterior angle, like in this case Z, is equal to the measure of the two remote interior angles. And remote meant far away. So it wasn't that it was connected to this close interior angle right here, but rather the two remote interior angles, the two that are further away, right here and right here. And so in other words, what I'm saying is that the measure of angle Z, or rather, I guess since Z is a variable, we'll just say Z. So we'll say Z is equal to X plus Y, all right? And that's the case here, that any exterior angle is always equal to the sum of the two remote interior angles, the two far away interior angles. So those are the two ideas that you need to have. And so now let's rock and roll through the homework. We're going to start with number 16. Okay, and on number 16 right here, we've got this triangle that has two of the angles given to us. We're just looking for the third angle. So for number 16, we can say, well, I know that all three angles, 71 degrees, 46 degrees, and whatever X is, all have to add up to be 180. And 71 and 46 come together, and that would be 117 degrees. And when we add X, we get 180. So if we subtract 117 from both sides, we would say that X has to be equal to 63 degrees. All right, if we were doing number 17, again, it's the exact same situation. We have a triangle in which we're given two of the angles. One of the angles is 56 degrees, the other one is 76 degrees, and the other one is X. We just don't know how big that is. So we add the 56 and 76, and we get, 132, if I'm not mistaken, plus X is equal to 180 degrees. Then we go ahead and subtract 132 from both sides, and that would leave us with X is equal to 48 degrees. All right, now 18, it starts to at least get a little bit more complicated. So we're going to take a look at 18. And with 18 here, we see that we've got this one triangle where we're given two angles, and the third one is X. And the other triangle, we're only given one angle. But the interesting thing is that they're connected with these vertical angles. So that unknown angle on the second triangle, that one right there, that one is going to be whatever the same value as X, because it's a vertical angle to angle X. So I'm going to start with the triangle that includes X and say, well, 46 degrees plus 36 degrees plus whatever X is, all has to add up to be 180. 36 and 46 would have to be, what is that going to be? 82? 82 degrees plus X is all got to be equal to 180. So then I can subtract 82 from both sides, and I get that X is going to be equal to 98. And so at this point, I know I've got 98, and so now I can figure out what Y is. Because in the other triangle, I know I've got 44 degrees plus this 98 plus Y all has to add up to be 180, because the three angles inside any triangle always add up to be 180. So 44 and 98 totals 142 degrees, plus whatever Y is, all has to add up to 180. Subtract the 142 from both sides, and I get that Y is equal to 38 degrees. Now let's take a look at number 19. Number 19, we see I've got two triangles that are kind of joined together there. And one of the triangles, I am given two of the angles, and the third angle is Y. So I've got 39 degrees plus 91 degrees plus Y is equal to 180 degrees. So 39 and 91 is 130 plus y is equal to 180. And so that makes it really simple. Y, when I subtract the 130 from both sides, y is 50 degrees. And then we go, okay, so y is 50 degrees. Now, that doesn't help us to solve for x on the second triangle. But what we can do is if we look at this picture a little bit closer, we can realize that 91 right here is actually an exterior angle of this triangle right here, okay? 91 is an exterior angle of that triangle. So therefore, 91 must be equal to the sum of the two remote interior angles, the one up top here and the one down low here. So therefore, we can say that 91 is the sum of x and 71. That's one way of looking at it. And so that's, I think, the easiest way to do this problem is I could just say, well, I know that x plus 71 degrees has got to add up to be 91. And when I subtract 71 from both sides, I get that x is 20. Now, you may have done that differently. You may have looked at it and said, well, I found the angle right next to the 91 right there. I found this angle right here and realized that that was, what is that, 89, and then 89 and 71, and then took that from 180. And you could do that, but you'll still get the same answer. X is 20. That is the answer. Okay, let's move on to the second set. All right, now we've got 20 through 23. These are all pushing that idea of those exterior angles. The exterior angles are always equal to the sum of the two remote interior angles. So with 20, I can see that x is an exterior angle out here, and so therefore it's equal to the sum of the two remote interior angles. So for number 20, I can just say that x is equal to 41 degrees plus 98 degrees. And when you add 41 and 98, I get 139 degrees. Okay? For number 21, again, x is an exterior angle, and the remote interior angles are 42 and 79. So I can say I know that x is equal to 42 degrees plus 79 degrees. And I add those up, and x is equal to, what is that, 121 degrees. All right, moving on to number 22. Number 22, this time at least it's a little bit different, because what they did is this time, instead of us wondering what the exterior angle is, they give us the exterior angle, and they give us one of the remote interior angles. So I got to remember that exterior angle equals the sum of the two remote interior angles. So the exterior angle, 119, is equal to the sum of the two remote interior angles, 46 and x. So at this point, I can subtract 46 from both sides, and I would get that x is equal to, what is that going to be, 73? 73 degrees, I think. Yeah. Okay, so x is 73 degrees in that one. And on number 23, again, they didn't, x is not the exterior angle. X is one of the remote interior angles. But I know the exterior angle, which in this case is 74 degrees, is equal to the sum of the two remote interior angles. So it would be 23 degrees and x. So I can subtract 23 from both sides, and I would get that x has got to be equal to 51 degrees. And there you have it. All right. Now, the thing I just want to remind you is that this angle, this interior angle that's right next to the exterior angle, that is never the remote interior angle. Remote means distant, far away. So if we're exterior angles right here, the remote interior angles are going to be the angles that are furthest from it. All right. Okay. Now, this problem is interesting. This is probably the most complicated illustration that we saw out of all the ones that we looked at. And so we're going to look at this, and you just got to figure out what angle 1 is, angle 2, angle 3, and angle 4. And so I'm going to start because number 24 has us. Says, well, what's the measure of angle 1? So I look at it and see, I'm just going to look at this triangle right here, and I can see that I have two of the angles. I've got 37 degrees and 116, and the other one is angle 1. So I know that whatever the measure of angle 1 is, plus 37 plus 116 degrees all have to add up to be 180. So 37 and 116 is going to be 153. So the measure of angle 1 plus 153 degrees adds up to be 180. So if I subtract that 153 from both sides, I get that the measure of angle 1 has got to be 27 degrees. Okay, and then let's go to number 25, which we're looking for the measure of angle 2. Now this was probably one of the most confusing out of any of these. As I look at angle 2, I realize that it is an exterior angle. But then I can ask myself and go, man, what are the two remote interior angles of that angle, because that can be kind of difficult to figure out, well, what angles would be the remote interior angles? There's so many triangles in this picture. So I think the easiest thing to do is to realize that, remember, that all of these must sum 180. They create a straight line. So that's really what I'd do. I'd say I know that the measure of angle 1 plus 74 degrees plus the measure of angle 2 all have to add up to be 180. And I just figured out the measure of angle 1, that was 27 degrees, plus this other one, that's 74 degrees, plus the measure of angle 2 add up to be 180. So 27 and 74 give me a grand total of what, 101? So I say 101 degrees plus the measure of angle 2 adds up to be 180. Subtract the 101 from both sides, and therefore the measure of angle 2 is equal to 79 degrees. All right, moving on. Now we get to angle 3. Number 26 says, well, find the measure of angle 3. And that one's really simple, because when we look at angle 3, we can see it's in this triangle right here. We've got 2 out of the 3 angles, so we just need the third one. So we can just add up all 3 of those and set it equal to 180 and say that 48 degrees plus 74 degrees plus whatever the measure of angle 3 is, all have to add up to be 180. 48 and 74 would give me 122 plus the measure of angle 3 adds up to be 180. Subtract the 122 from both sides, and you get that the measure of angle 3 would have to be 58 degrees. Okay? And lastly, let's talk about the measure of angle 4. Now, 4, good news. This is an exterior angle, and other good news is it's a little bit easier to see it's an exterior angle of which triangle. Okay, there's not multiple triangles connected to it. There's only this one right here. Okay, this triangle right here is connected to that angle 4. And so if this is the exterior angle, then the remote interior angles would have to be the angle here and the angle here. So that's one way of looking at it. If I wanted to do it and go, well, I know the exterior angle is equal to the sum of the 2 remote interior angles, that would be the easiest way to do this one. I could look and say, well, I know that, I'll put it right here, 27. I know that the measure of angle 4 has got to be equal to 122 degrees plus 16 degrees. And I just add those up. Measure angle 4, it's got to be equal to 138. And that's true. Now, but let's say I was struggling and maybe that didn't seem like an easy way to go, or I didn't see that. What I could do is I could try to figure out what this other angle is right here. And I'd know that angle 4 is supplementary to it. And that's another possibility. I'd take 16 and add it to 122. I'd get 138. I'd subtract that from 180, and I would get this angle right here. When I take 138 from 180, I'd get 42 degrees. And so that is to say that that angle is 42 degrees. And then I'd say, well, I know angle 4 is supplementary to 142, so 180 minus 42 would again get me this 138. So I keep coming back to the same answer. So hopefully these are making sense to you. The last one, it says a pennant, which is a flag, is in the shape of an isosceles triangle. One leg of the triangle is fastened to a stick. The stick forms an 84-degree angle with the other leg. What is the measure of each remote interior angle in the triangle? Whew. All right, well, let's take a look at this. So I think about it and go, okay, so a pennant typically looks like this. All right, a pennant is in the shape of an isosceles triangle. One leg of the triangle is fastened to the stick. The stick forms an 84-degree angle with the other leg. What is the measure of the remote interior angles of the triangle? Okay, so this is what I'm looking at. And so I'm saying, okay, so here's a pennant. A pennant is a triangular flag. And so I'm seeing that the remaining leg of the triangle would be right here. So that leg is fastened to the stick. And it says, but the stick also makes an 84-degree angle with one of the legs. Okay. Now, lastly, it said that this is an isosceles triangle, as all pennant flags are. So this side is congruent to this side. And in this case, if we've got 2 congruent sides, we haven't talked about this yet, but we would have 2 congruent angles. So therefore, this angle would have to match whatever this angle is. That's a theorem and a postulate that we have not made it to, but it goes without saying. Hopefully you've heard it before, and if you haven't, it's okay. We're going to get to it. But so in this case, we get an isosceles triangle, 2 congruent sides. We must have 2 congruent angles. This is 84, so the other one is 84. So we know we have one 84-degree angle. We know that this other one has got to be 84 degrees. And so the question is, what's this other one right here? This would be the other remote interior angle. I'll call it x. But we know that all three of them in any triangle, all three have to add up to be 180. So 84 and 84 gives me 168 degrees plus whatever x is has got to equal 180. So you subtract 168 from both sides and x would have to be 12 degrees. So the two remote interior angles, the two far away angles would be 84 degrees and 12 degrees. And there you go. That's the homework. I hope all of this made sense. If there's a spot you need to rewind and go back and take a look at the video, please do. Otherwise, let's move on. I'll see you guys later.